Hi, in this video, we want to take a look at coloring polygons in Leaflet with R. So we're going to create Choropleth Maps using Leaflet in R. All right, so this funny word means that what we're going to do, we're going to put down a region on our map, and we're going to color it corresponding to data. So the best example of this would be, let's say, like the 50 states. We put down the 50 states, and then we color each state by, let's say, population size, or let's say population density, maybe something like their state bird. So like cardinals would be like red. A lot of states have cardinal, by the way, as their state bird. So what we want to do is take in some data, some geospatial data that has the polygons aspect. Then I want to incorporate some other data that I'm interested in, and then plot the polygons, take that data, and determine the colors. Okay, so what we're going to do, we're going to first load some data. All right, so if you go to the Pasco County Public Schools in Florida, and you can get their GIS data boundaries for their school zones. For this example, we're going to work with the elementary schools because in almost all school districts, there's more elementary schools than middle school or high schools. And so this will work out pretty well for us. Now, here is where I download the data. Thank you, Pasco County Public Schools, by the way. Now I need to read in the data. All right, so here I downloaded it as a shape file. And so I'm going to use RGDAL. I'm going to use the read OGR function to read this in. All right. So now when I do this, we get some feedback. We see where we got it and what are the names of the layers. And then we can see that there are 48 polygons for this particular data set. And there's 3 fields. Okay. So now, when I got this, I took it, I tried to put it in the leaflet, and it didn't work out. And I was having trouble, like, what's going on with this? And what I did was I used the str function to look at the structure. Remember, str is the structure function in R. And I took a look at what is it that I have. And I saw really weird numbers, because I know what the latitude and longitude of Florida is, and the numbers were nowhere near anything I've ever seen for latitude and longitude. So what I did was I looked up a standard projection to give it, and I changed it. So if I look at the default projection for the data set. All right, so now let me back up. One thing I want to point out, I think is important. Notice my naming convention here. All right, what I do is I like, when I name something, first I name the class or the object, what it is, as what type of structure it is. Then I give it a descriptive name as I work through my project. That way, 6 months from now, when I'm looking at my code and I go, hey, what is this object? I know it's a spatial polygons data frame. Now, spatial polygons data frame is a really good object structure for us to work with, because it contains our data and our polygons in one very nice and neat package. Makes it easy peasy lemon squeezy to be able to to work with this, rather than other file formats where the data is here and the polygons are here and I have to work with it separately. Here, everything is in one nice, neat little package for us, almost with a bow on it. All right, so when I look at the projections of the original data sets, so there are several slots for a spatial polygons data frame, and the last one is the projection for string, and here it is for us. All right, so we've got latitude and longitude, and this is kind of an unusual format. I didn't recognize this. I personally haven't worked with this projection before. And now this will work because I did plot this using the SP package to plot to make sure that it was a good data set. but Leaflet wasn't working with it. Leaflet didn't like it. And so what I did, just to make things work, I used the SP package, SP transform. So here's the object I want to transform. And here I'm grabbing the coordinate projection that I want. So here I'm going with the, by far the one that I've seen the most on the internet, the most standard one is WGS 84. Okay. And now to get that actually in the right way that we want to get going, I have to pass this character string into SP's CRS, its coordinate system function. And what this will do, this will convert it into the format that we need to work with in the transformation. And it worked like that. Perfect. All right, so now when I call the projection, we can see now is the standard one, and this is the projection you'll see a lot more commonly as you look through help documentation for Leaflet, SP, SF, so on. All right, so let's go ahead and create an initial map. So what I want to do, this is not the punchline of this video. This is just to show, hey, where are we going? What are we trying to do? Well, I'm going to get the Leaflet package loaded. And just real quick and easy, I'm going to pass my spatial polygons data frame to Leaflet. I'm going to get a background tiles, and I'm going to add the polygon. So this is just a quick, bare, easy thing. So what I'm doing here is I'm plotting the polygons with the default settings, and I'm putting the default map behind it. So here I can see where are the school zones and in relation to each other, where they're shaped, and I can see where on the map of Florida all the school zones are. All right. Over here is Zephyr Hills, good place to go skydiving. Okay. So now previously I mentioned that spatial polygons data frames have a slot for the data. And this is one of the great, really, really nice features about these, because everything is contained in one spot for us. And so if I want to take a look at that, I have to use the @data to grab that slot. Notice that I'm not using a $, I'm using an @ symbol. And we can see that we've got school name, the abbreviation that they use for their schools, and we have their cost center. The cost center is the ID number within the school district. And this is what's used throughout the Florida Department of Education. Now, different schools have different ID numbers within their district. Districts also have an additional 2-digit number. And for Pasco County, if I was to go through and I was to take this number and start looking at other school districts, I would see that these ID numbers are not unique to the schools. If I want a unique ID number, I need county ID and school ID together to get a unique ID going if I want to go across the state. We are only looking at Pasco County, so I don't worry about the county ID at all. So like for this project, for this coloring of the school data, a good example of where that would come up is, let's say I wanted to buy a house and I could live in several different counties. I would want to plot all the counties together because I would like to be able to see like what is the school grades and be able to compare better. All right, so now I'm going to load the school data. Now I got this data set from the Florida Department of Education. Now you'll notice that this is the 2018-2019 school grades. Why is it only 2018-2019 when currently, when I'm filming this, it's 2021? All right, so remember COVID screwed up school grades for 2 years. So the 1920 school year, school grades didn't happen because COVID prevented testing. The year after that was that big COVID year of kids being remote, and schools had the option of not opting into school grades. So in that scenario, I really can't trust the data. And currently the current school year data is not available. So this is the most recent school grades for reliable results. This is the last school grades before COVID kicked off. All right, I'm going to read in the data. And so the Florida Department of Education saved it as an XLS file. I'm using read XLS. Now this will be a tibble, and I personally don't like tibbles. They're advertised as working the same as data frames. My experience is that's not true when you go outside of the tidyverse. So to resolve that, what I'm doing is I'm converting it to a regular old data frame and just running with it. And so by doing as.data frame, it's just a data frame, it's not a tibble, and it will agree better with a wider range of packages. It'll work better with packages outside the tidyverse. Now, something I always do with all my data sets is I make clean names. So these are syntactically correct names, and I like to use like snake case with uppercase letters only on the first of each word. That's my preference, what I like to do. And now I'm going to subset my data to the ones I'm going to be interested in working with. And so I'm restricting everything down to the Pasco County schools, and I'm restricting it down to the data that I have in my Polygon data set. All right, so this data set, if I was to go here, if I didn't do the filtering, this would be for all schools across the state, 2018, 2019 in the data set. Here, what this will do, this will grab the charter schools, elementary schools, middle schools, and high schools, and any other special centers they have. Okay, I don't want all that. I just want the classic brick and mortar elementary schools. And so those will be the ones that I'm only grabbing the ones that are inside my spatial polygons data frame. So this step right here restricts it only to the schools that have an ID inside my data frame. Because when I'm plotting polygons, so let's say like there's a virtual school. Well, virtual school isn't going to have a school zone, therefore I don't want to plot it. Same is true like special centers that take in students from across the entire county. And I'm going to convert one numeric column percent of total possible points to numeric values. And you'll notice that when I loaded the data originally, I put call types equals text. I do that intentionally. That way I know I'm not going to have any data loss, and things don't get converted to factors. Factors are kind of a pain inside R. And things like that ID number has a leading 0. If I had that loaded as numeric, I would lose leading zeros. Therefore, I just want everything as a text. And now let's just go ahead and take a look at the data we will actually be working with. All right, so we've got school number, we have the school grade, and percent of total possible points. Now you'll notice that 77 is an A. And over here, 70 is an A. In fact, the cutoff for an A, I think, is like 64. So the scale is not the same as the regular school grades that we're accustomed to. And that's all right. That's our data. All right, so now let's go ahead and start doing some data prep. All right, so now what I'm going to do is I'm going to merge the data frame that's in my spatial polygons data frame with that school grades data that I got from the Florida Department of Education. I'm going to use a merge statement. Now, notice what I do is I grab my object and the slot I want. I grabbed at data. I grabbed at data. Here's the data I want to tack on. I want to merge or I'm doing a left join. I want to do a left join with this as the right data set. This is the left data set. We're joining on cost center equaling school number, and this specifies it's a left join. Okay. And now here, just to make sure I don't have any missing value issues, this part here finds all of the data that is a character string. And then, so it's categorical data. This finds my categorical data, labels it character. And this step goes through and makes sure that I label missing values as missing. I like to explicitly put in missing for my missing values on categorical data. All right, so now let's take a look at our data. All right, so here we have our school grades like this. And you'll notice that here I have a missing value for the Starkey Ranch K through 8. Okay, why is that? I don't know. I don't know why that happened. I'm not a part of Pasco County Elementary Schools or Pasco County Public Schools. I don't know the story behind this. It might be the school changed. Maybe a previous school was there. So remember that the polygons I'm grabbing are from 2021 and the school grade data is from 2019. COVID happened in between. There's plenty of reasons why things aren't matching up fully, but I know that this is different than what's typical. And here we can see our percent points earned. All right, so now I'm going to go through, I'm going to define the colors going by the categorical data of school grade. So I'm not going to consider the numeric value. I'm going to consider A, B, C, D, F, incomplete, or missing. All right, so how I choose to do this, there's a bunch of ways to do this in R. The one that I find the most convenient is to use a color vector and then index inside that color vector. All right, so here I define what the colors are. Here I say which color matches which level. And remember that I have everything organized as character values instead of factors. If you're working with factors can be much more difficult. So here is the color. I'm going dark green for A. Boom. B is green. C is yellow. D is red. F is dark green. And then incomplete and missing are both gray 50. Okay. And so this chunk of the code defines the color vector and how I get it into my data frame. All right, so I take the color vector and I index on the data, and this works out perfectly. Now, for this next step, what I'm going to do for something that's coming up, I go ahead and I create a new data field, school name. You'll notice that this is, uppercase and lowercase. Well, this version is strictly uppercase. I create a new field in my data frame just for the purpose of upcoming steps. And I order the schools by the percent of points that they got. So you'll notice I've got factor. I'm saying that I want school name to be the factor, and I'm ordering the data by the percent of total points earned. So I order inside here on percent total possible points, and this will make things easier to look at in a moment. All right, so now I'm going to define the colors. All right, so this is my personal trick for getting numeric data to colors very easily. What I do is I do a quick and easy ggplot that as part of the building of the ggplot does the color build for me and gives me a good plot to include in my presentation. All right, so here, what I've done is we can see that like Trinity Elementary had the most percent points earned, while Rodney B. Cox had the lowest. And you can see that ggplot did a very nice job of coloring. Now, if I was actually showing this plot during a presentation, I would make this a little bit less crowded, but I think it's pretty good as is. Or maybe I could split it into two groups. And I like to order my categorical data by the target variable because it's much easier to see how things relate to each other when it's presented in this manner. The labeling is kind of overlapping, but we have a good idea of what's going on. What I'm going to do is I'm going to use these colors to color my Choropleth map. So how do I do this? Well, what I do, I go in and I just build that bar plot using ggplot. Easy peasy lemon squeezy. You'll notice that My fill is percent of total possible points. And my X is school name. Those are the two critical aspects that I need for this. School name and percent of total possible points. And something I do, another step actually is to have cost center in there. Notice that I have cost center included in the AES aspect of ggplot. What this is going to do, this is going to include cost center inside the data frame for the ggplot build data. And then here I'm just coloring. I'm using scale fill gradient 2. The reason why I'm using this is because I like stoplight colors when I'm talking about good and bad things. Low is dark red, middle is yellow, and then high is green. So I've got bad is red, good is green, middle is yellow. All right, and this is a very good scheme for communicating to people because people know stoplights. Now here, the midpoint, I played around with this. I'm not 100% satisfied, but I felt like 50 was close enough. And, I figured I played around with it and no value really was satisfactory. I felt like this was close enough. All right, so let's take another look at that plot. Now what we actually want is not this plot, it's its build data. So let's go ahead and get the build data off of this. So here, what I'm doing is I'm calling ggplot build. So there is the plot I created, I called P. I'm putting into ggplot build. So what this will do, if I just called what's highlighted blue right here, is it'll give me all the features that R needs to plot the bar plot that we just looked at. Now this specifies the data that's used in the build. Now, the number here corresponds to which geome we're talking about. So you see how I have a 1 here? That means it corresponds to geome call right here, because it's a column plot. If I was interested in the geome text data, I would have had 2 because that's my second geome. Now here, this is the fill value. And remember that I included cost center inside the AES statement because cost center was included in there. This is included in the ggplot build data. Okay. And so I plot that on there. Now at this point, I've got everything set up to build the data or to build the colored map that I want. So first, let's go ahead and build it by the categorical data for coloring. So I'm going to take my spatial polygons data frame. I'm going to pass it to leaflets. I'm going to say, hey, put down a tile. So I'm going to choose the black and white tile as the layer below. The reason why I choose that is I don't want colors from the map underneath showing through and like befuddling the color of my polygons. And so I'm choosing black and white. Now I'm going to add polygons. Now this weight says, hey, don't make too thick of boundaries. Just make boundaries, but not like crazy thick. All right, so this tilde notation, what's going to happen is that if I use tilde, Leaflet is going to look inside the data frame for my spatial polygons data frame. It's going to look for the column color grade and then grab that data for us. That way I don't have to type out the whole name of it. Very nice and easy. And then here I can give a command to do a paste so I can get a better label. And now here I'm going to make things opaque. All right, so if I put 0, I'll be able to see through as if there's no coloring. If I put a 1, it's going to be solid. I won't be able to see through. I played around with it. I feel like 0.8 to 0.9 is good for this purpose. And now just so that I have the borders easier to see, I go ahead and I put down the color of black with a weight of 0.5, just so that I can see the difference a little bit. All right, so now here I can see that this school zone got a B with 55% of the points. This one got 70%. This one got 60% as a B. This one got a C with 47%. Now over here is where I have a missing value, and you notice that since I used base R put NA as an actual NA. I really shouldn't have done that. I should have just modified the label, done something with it, but oh well. I like to just point this out. Anytime you're using base R string manipulation, if it's NA, it's going to literally print NA for you. That may be good, that may be bad. Just be aware of it. And we can see over here that Rodney B. Cox Elementary is the lowest performing school in the school district. All right, so now I want to look at the same map, but this time I want to have a little bit more nuance in my coloring. So I'm doing everything the same, except I'm going by that fill column that I got from ggplot. All right, so the ggplot, remember when we looked at the bar plot, there was a gradient of the colors as we went from top to bottom. Let's take a look at what we get. So now here, the colors are not as distinct. It's harder to distinguish between these two, but it's also more nuanced. So here, this is a B, this is an A, all right, so here's a B, here's a B, and we can see that this one was a lower B than this one because this is closer to yellow. We got yellow, and this also gives me a sense of how close to a C was Rodney B. Cox Elementary. How close was Rodney B. Cox Elementary to an F? In the other presentation, I have no idea. Maybe it could be like high up in its range or down low. We don't know. This gives us a little bit more nuanced information. And so this gives me a much firmer view on like how strong is Trinity Elementary compared to the rest. Here's Odessa. Odessa is an A, but it's not as strong of an A. We can see that Trinity Oaks is an A, but it's weaker than both of these. All right, well, I hope you enjoyed the video. That's all I've got for you. Take care and goodbye.